Hello everybody and welcome back to another video by Funlearn Tutorials. In today's video we will be continuing with the objective that we had started with in our previous video. That is, we are trying to compare between the dynamic setup of a game and what will happen if we try to convert this dynamic game tree representation of the game into a somewhat static representation, and what will it be called, what are its drawbacks, and what are some results that we can find from this, which are, as I have mentioned before, very pertinent in the field of game theory. So I assume that you have seen how this game can be solved. It's a dynamic game and it has been represented in a game tree format, as I have mentioned here, and we use the principle of backward induction to solve this game. I will be linking the solution for this game in the top right corner of the video as well as in the description box, so I highly suggest that you have a look at that first. Now that we know how this game can be solved, let us now try to convert it into a static form game. Now usually we convert static form, we represent static form games through matrices, so that is what we will be trying to do. In this case there are two players, right? So we will be having accordingly two sets, but here the representation will be a little different because the player 1 has two options, capital A or capital B. Here we see that player 2 has two options, small a and small b, in the dynamic game tree form. But actually what we see is player 2 has essentially 4 options. Let me draw the game and then it will become easier for you to understand. So here we have the matrix setup, and as you can see I have decided to mark player 1 along the rows and player 2's strategies along the columns. Now you might be wondering, of course player 1 has two strategies, either capital A or capital B. So we can understand that we will put capital A here and capital B here. That is, we will try to find out what happens if player 1 chooses capital A or player 1 chooses capital B. But the question is, why have I drawn 4 columns here? The reason is simple. The player 2 seems to have two strategies, either small a or small b. But when we convert it into a static form game, that is not how we represent it. We represent the column headings as small a, another will be small a, small b, another will be small b and small a, and the third one, or this rather the fourth one, will be the small b strategy. Now why have I put it in such a peculiar form? When we consider strategies, essentially we think of it in this way: whatever the other player decides to do, I will have a list of things that will tell me what to do. It's like a lawyer gave me, look, if player 1 does this, you will have these options. If player 2 does this, you will have these options. It's like a system, it's like a list of things that I can do once player 1 has made a decision. So I have to make the decision following player A, right? It's a dynamic game, it's a sequential game. So player 2 has to make his or her own decision based on observing player 1's decision, which has taken place in the first chance. So player 2 is sequentially in the second position, and that has to be considered when we consider the static representation. So the fact that I am using 2 letters here is because this is a sequential game, is because it is a dynamic game. Now what does small a mean? Small a means if player 1 chooses capital A, player 2 will choose small a. If player 1 chooses capital B, then also player 2 will choose small a. That is, whatever player 1 chooses, player 2 will always choose small a. That is this meaning. So it's 2 A's means whatever player 1 chooses, player 2 will always choose small a. That is what small a means. Similarly, small b means if player 1 chooses capital A, that is the first option, player 2 will choose small a. But if player 1 chooses capital B, player 2 will choose the second letter, which is small b. So essentially the first letter gives you what player 2 will do if player 1 chooses capital A, and the second letter gives you what player 2 will do if player 1 chooses capital B. So we can essentially build the matrix based on these strategies, and we can use the data from here to fill this box. And using this we fill up this box. So let me try to find out what will be going for these boxes. Now consider this cell first. Player 1 chooses capital A and player 2 chooses small a. This means player 1, whatever player 1 chooses, player 2 will obviously choose small a. So if player 1 chooses capital A, player 2 chooses small a, that means the payoff is 3, 2. So let me just fill it here. This is 3, 2. Right, this is 3, 2. If player 1 chooses capital A and player 2 still chooses small a, then the payoff will be similar. So it will be 3, 2 again. Now if player 1 chooses capital A but player 2 chooses small b, the result will be different. It will be 2, 4, because player 1 chooses capital A and player 2 chooses small b. So it will be 2, 4 again. Right. So this will be 2, 4. Again, if player 1 chooses capital A and player 2 chooses small b, then the result will be 2, 4. Now try to understand that if player 1 chooses capital B and player 2 chooses small a, so player 1 chooses capital B and player 2 chooses small a, the result will be 8, 2. So this will be 8, 2. This will be 8, 2. Try to understand that if player 2 chooses capital B, small b, when player 1 chooses capital B, then it's this and this. So it's 3, 3, right? So this cell, which is B and the B, so this will be 3, 3. So that is how we can fill up this entire matrix. You can again check that this cell will be again 3, 3, because we consider the second option for small, the first player chooses capital B, and since the first player is choosing capital B, we will look at the second letter of option of player 2, that is also small b. So it's B, and this is B, A, because B is the second letter. So we look at the second letter, which is small a, that means it's B, A. So it's B, A, which is 8, 2. So this is how we can represent a dynamic game into a somewhat format of a static game. I repeat that this is not a static game, this is a static representation of a dynamic game. In the next video, we will try to solve this setup. Again, of course, we cannot use now backward induction, because backward induction is used for game 3. Now we will use a different way of solving this matrix representation, static representation of a dynamic game, and we will try to find out if there is any inconsistency in the game.